Hello everyone, welcome to my channel Economic Architecture made in Inversiones Brain Group. Today we will be working the consumer theory, the fourth class of the microeconomics theory. Okay, let's go. Class 4 microeconomics theory, consumer theory. How do people choose what bundle of goods to consume? We cannot observe this process directly, but can we come up with a model to capture the decision-making process so that the prediction from the model matches the way people behave? If we can build a sensible model, we should be able to use the model to understand how choice varies when the economic environment changes. This should also help us design appropriate policy. This is the text in the chapter, and as we go through the various steps, you should keep the overarching goal in your mind and try to see how each piece of analysis fits in the overall scheme. Once we build such a model, we use is to analyze how optimal consumption choice respond to price and income variations. Preference and utility. The theory of choice starts with the rational preference. Generally, preferences are primitives in economics. You take these as given and proceed from there. The task of explaining why certain preferences exist in certain societies falls largely under the domain of subjects such as anthropology or sociology. However, to be able to create a model of choice that has some predictive power, we do need to put some restriction on preference to roll out irrational behaviors. Just a few relatively sensible restrictions allow us to build a model of choice that has great analytical power. Indeed, this idea of creating an analytical structure that can be manipulated to understand how changes in the economic environment affect economic outcomes underlies the success of economists as a tool for investigating the world around us. Indifference curves. While we can represent preference using a continuous utility function, we can draw indifference curves. An indifference curve is the locus of different bundles of goods that yield the same level of utility. In other words, an indifference curve for utility function, utility got x and utility got y, is a given by utility got x and utility got y equal k, where k is some constant. As we vary k, we can trace out the indifference made. Not that an indifference curve is simple, a level curve as utility function, just as you draw contour on a map to represent, say, a mountain. So indifference curve draw for two goods are contour plus of a utility function over these two goods. The first graph a convex indifference curve. The second graph a non-convex indifference curve. Okay, budget constraint. Once we have specified our model or preference, we need to know the set of goods that a consumer can afford to buy. This is captured by the budget constraint since consumers are generally taken to be price takers. The budget line is a straight line. You should be aware that budget lines will no longer be a straight line if a consumer buys different units at different price. This could happen if a consumer is a larger buyer in a market or if the consumer gets quantity discounts. Utility maximization. The consumer chooses the most preferred point in the budget set. Its preferences are such that indifference curves have the usual convex shape. The best point is where an indifference curve is tangent to the budget line. The first order condition, Lagrangian method. The first order condition for a constraint maximum are, looking this in exposition from the first two conditions we get. Derivate the Lagrangian method. Okay. Second order condition. The first order condition above are by themselves not sufficient to guarantee a maximum. We also need to second order condition to hold. Is better to derive this formally once you have learned matrix algebra, which allows a relatively simple exposition of the second order condition. For our purpose here, not that the diminishing marginal rate substitution condition is sufficient to guarantee that a maximum accounts of the points satisfying the first order condition. They should also be clear to you from the graph. If indifference curves satisfy the usual convexity proper, there is an interior tangential point with the budget constraint line at which the maximum utility is attained. Example: a consumer has the following cut-Douglas utility function, where alpha beta major 0, the price of x is normalized to 1, and the price of j is p. The consumer income is m. Derive the demand functions for x and y. Okay, let's go. The answer. Let's go to construct the answer. The consumer problem is a follow maximization maximize x, y subject to x plus price y equal m. Using the Lagrange multipliers method, we get marginal substitution utility got x divide marginal substitution utility got y is equal price got x divide price got y. Okay? Now, this implies this implies alpha for x derive for y beta divide beta for got x for y is equal 1p divide p. Now, alpha for y divide beta for x is equal 1p. Simplifying. Using this in the budget constraint and solve it, we get the demand functions. The answer is x en función pi m equal alpha m for m divide alpha plus beta. Finally, y en función price and rent is equal beta for m divide price multiply alpha plus beta. Okay, this is the solution, this example. Okay, thank you very much for following me in this video. Until a video. Okay, bye bye.